Okay guys, so for part A, he's asking us to use the random number provided in the table below to determine the simulated error terms, where e sub t is distributed normally with a mean of 0 and a standard deviation of 3. You can see from here that I've inputted the error terms into Excel over here, and we're going to be using that in addition to the z values to record the actual error terms. So recall from basic probability that your z value is going to be equal to your e sub t minus 0, which is the mean. This quantity, with this quantity all over your standard deviation. You know your standard deviation is also going to be 3, so let's adjust that. So from here, you know your your e sub t is equal to 3z. How do you go from here to, how do you go from these random numbers to your error terms? So notice that the random numbers are all in decimal form. They actually correlate to probabilities on the standard normal distribution. So you can use the given chart that Maxwell gives you of the z values over here in order to actually find your error terms. So first, let's start with the fact that your error terms are equal to 3 times the z value. You use these random terms right here plugged into this table right here to find the actual z values. So this table is kind of weird in the fact that it records the z values from 0. So in order to adjust for that, you're going to have to make a few adjustments. So if the random terms are greater than 0.5, you want to find the random term minus 0.5, and if the random terms are less than 0.5, you want to do 0.5 minus the random terms, and then you'll take that number and you'll stick it into this area right here in order to get the actual z value. So let's do an example with the first one. So the first one is 0.8413. You can do since this is greater than 0.5, you 0.8413 minus 0.5. That gives you 0.3513. If you go to the standard table, oh, did I? Excuse me guys, sorry. Typed this wrong. Sorry, this is 0.8413. Alright, so if you go to the standard table, you know it's 0.3413, which will be equal to 1.00. So you know that's going to be the z value. And from there, you can multiply that by 3 using this equation we derived earlier in order to get your error term. So your error term will be 3.0. You can do the same for the second one. So in case of the second one, it's actually less than 0.5. So we're going to use this thing right here. Since it's less than 0.5, you do 0.5 minus the random term, and then you make the error negative. So in this case, you do 0.5. 0.5 minus 0.0062. That gives you 0.4938. Go to the table of z values. That's the number again, 0.4938. And let's try to find that sucker. That will be right here. So you know that the z value that corresponds to this value is actually 2.50. So again, you multiply that by 3. And you get 7.5. And since this is actually less than 0.5, you want to make this error term negative. So it's negative 7.5. Alright, so you can repeat this basically for the rest of the random terms. Just note of their position in accordance to 0, or I'm sorry, in accordance to 0.5. So if they're greater than 0.5, you do this right here. And if they're less than 0.5, you do this right here. In the next video, I will explain to you guys how to do parts B, C, and D of the same problem.